All right, today's lesson is factoring trinomials, and this lesson is extremely important in mathematics. So we really hope that you put the time into this to make sure you understand it and take it seriously, because you'll be doing this for the rest of your high school career, absolutely, and into college for those who study anything to do with math in college. So let's just get some vocab first. Let's start with the word factoring. Factoring means to make multiplication. So to figure out how to make something into looking like multiplication, that's what factoring does. A trinomial is a polynomial with 3 terms. So if I just had x squared, let's say, that's one term. The second term, if I added a second term, that would be, let's say, 9x. And then that would be a binomial. And then if I had a third term, then now I have a trinomial. And the trinomial has to be in this we want it to be in this structure, with the x squared is the highest power first. And then we have an x to the first power term, and then this last term is the constant. There's no x on that 18 there. The structure then of a trinomial in general would look like this: ax squared plus bx plus c. So in this particular example, the a is the number in front of the x squared, which we're working with an imaginary 1 right here. Like, we don't have to write the 1, but our a value would be 1. The b value is the second term's value, this is what's called a coefficient, the number in front of the x, the coefficient. And that in this problem would be 9. So we have a is 1, b is 9, and c is 18 for this problem. Now, this is a trinomial that we would then need to factor. So let me write the trinomial again. And we're trying to factor this, which I've purposely picked the problems to all be factorable. Sometimes there's things that cannot be factored, but in today's work, it'll always be able to be factored. So when I factor this, I need to make this multiplication. Well, if you can recall, what we've done before was we multiplied binomials together and they created this answer. So we're just doing basically the opposite of what we've done before. I've given you this, which used to be the answer. We need to go backwards and figure out what would go in the parentheses to FOIL and get you back to here. So we know that when we FOIL, like, the first term is this, I'll use pencil, this times this, and it needs to make the x squared. So in the first slot of our binomials, you'd have to have an x and an x right there. So we can always pretty much see that right away, that there's an x and an x right there. Now, the other numbers right here, here's what we noticed had happened before, is that this number here came from multiplication. So that's the multiplication symbol. And this number here came from addition. That's the addition symbol right there. So what we need to do is think about what numbers multiply to 18, but then also add to make 9. So what numbers can you think of? So I'm going to write it over here as like a little scratch work. I'm going to write 18. What numbers multiply to make 18, but add to 9? So if I'm just going to do this for this one problem, I'm going to write some factors of 18 down. 18 times 1. I'll just write 18 and 1 over here. So they multiply to make 18, yes, but do they add to make 9? No, these do not add to make 9. Let's try another factor, 2 and 9. They multiply to make 18, but can these two numbers add and make 9? No. So this didn't work, this didn't work. 3 and 6. 3 and 6 multiply to make 18, yes. Does 3 and 6 add to make 9? It does. What that means then is that these are the numbers that go in here and find the answer to the question. We've found the answer to the factored version here. So we have x squared and x squared, or x and x to make the x squared, and then these two numbers have to come from multiplying to make 18, adding to make the 9. So it's multiply to make the third number, the c value, add to make the b value. Let me do a couple more examples of that. So let's say I had to do x squared plus 12x plus 10. And my goal is to factor this, is to make it multiplication. So this is now multiplication if it's in this format. So we know to make the x squared, it's got to be x and x. And then I'm just going to make a little note on the side for my scratch work. I have 10, I write here. I need to find what multiplies to make 10, but adds to make 12. So factors of 10, like I can think of our 5 times 2. That multiplies and makes 10. It does not add to make 12, so that's not the correct factor. Oh, sorry, I messed up. This should have been a 20. Let me change that. My bad. So that should have been 20. So multiples of 20. There's 5 times 4. Multiply and make 20. But that does not, 5 times 4 do not add and make 12. So that's not it. How about 10 times 2? 10 times 2, multiply and make 20. And the 10 times 10 plus 2 adds to make the 12. So these are the numbers. It does not matter then, this is the answer. It does not matter if you put the 2 here and the 10 here. It's the same exact thing. All right, well, let's try one more here. Actually, I think we should do a couple more because you might be curious what happens if they're not all positive. So let's try a different scenario. Let's do this one. Okay, so for this trinomial, I need to write down negative 15 over here for my scratch work. Keep in mind that is a negative 15. So it needs to multiply and make negative 15 and add to make positive 2. So what are some factors of negative 15? I can think of 5 times 3. Now, 5 times 3 makes positive 15, but how I need to make negative 15, how could I do that? One of these needs to be negative. I can't just choose whichever one I want, though, because I also need to make them add and make a positive 2. So, for example, if I put negative here, positive here, now these multiply and make negative 15, but do these add and make positive 2? No, this would add and make negative 2. That means I've got to fix my signs here and switch them. Let's try this. Make the 5 the positive and the 3 the negative. So now, if they multiply, it makes negative 15. If they add, does that make positive 2? Yes. So I've got the right numbers. I can put them into my parenthesis then. X and X goes right here. Plus 5 for one of the parentheses and minus 3 on the other. And I could always check my work by just foiling it out, and it will look exactly like what we have up top. Let's do another one. You might think you got it, but just know that there's one more type. Like now I have a minus sign here and a plus sign there, which is a little different. So I have to multiply numbers to get 30, so I write down 30. Note it is a positive 30. Now I need to find factors of 30 that add to make negative 11. So factors of 30 are like 30 and 10. Can I make 11 with a 3 and a 10? Nope. 15 and times 2. Can I make 11 with that by adding? No. There's no way to get to 11 with those. 6 and 5. Can I get to an 11 with them? I can. I do need to think about my signs here. So I need to make them multiply and make positive 30. These would make a positive 30 when multiplied. And then when they add, they need to make a negative 11. If I add 6 plus 5, that makes positive 11. So something's off here. I got to fix some signs. To make negative 11, that would have to be a negative 6 and a minus 5. Let's check now. Would a negative 6, negative 5 multiply and make positive 30? Yes, a negative times negative makes positive 30. Would these add and make a negative 11? Negative 6 plus negative 5 is negative 11. So these numbers fit. There's not any, you can't, like, if you're wondering, like, are there different ways to, different combinations of numbers? No, there's only one fit. So you got to make sure you get it exactly right. There's not going to be two answers. The only way you could have two answers, I guess, is you could put the minus 6 in this parenthesis and the minus 5 in this parenthesis, or switch them. It doesn't matter which parenthesis gets filled in where, but one of them's minus 6, one of them's minus 5. So that is the answer. Let's put this information into our notes then. So the first thing is I want to write down, we have the form of a trinomial is ax squared plus bx plus c. And we need to find, what we're doing here is find factors of c that add to b. All right, let's go ahead and try some examples.